This video is going to show you how to use the quadratic formula to solve quadratic equations. We're going to be looking for what are called roots. You guys have been finding roots, you just didn't know that we were calling them roots. When you solve a quadratic equation such as x squared plus 5x plus 6 equals 0, and you factor it out to x plus 3 and x plus 2 equals 0, your two answers of x equals negative 3 and x equals negative 2, these are the roots. They're also called the zeros or solutions. Zeros, roots, solutions, and even in a couple weeks when you guys learn more about graphing, you're going to learn that they're also called intercepts. So if I say roots, it's like trying to solve. So here's the quadratic formula. It comes from looking at the standard form of a quadratic equation, ax squared plus bx plus c equals 0. You identify the a, the b, and the c numbers, and you just plug them in to the b's and the a's and the c slots in the formula. It's pretty straightforward. You do have to memorize this formula, and you'll be asked to use it many times. So let's apply it to our first problem. First off, I have to make sure it's in standard form. I look and see if there's a 0 at the end, and there's not. There's a 5. So the first step here is to move the 5 over to the left by subtracting 5 on both sides. So 2x squared plus x minus 5 equals 0. Now it's time to start identifying our a, b, and c. A is 2. B is positive 1, and C is negative 5. Now we're going to start plugging it into the quadratic formula. X equals negative B, which in this problem is R1, plus or minus square root of b squared, so again that's 1 squared, minus 4 times a is 2, c, negative 5, all over 2a, 2 times 1, 2 times 2, 2 times 2 is a. Now we're going to start simplifying what we can. Negative 1 is still there. But inside, we now have the square root of 1 plus 40. So that's 4 times 2 is 8, and 8 times 5 is 40, and a negative make a positive. All over 2 times 2 is 4. And we'll simplify the inside of that. Ooh, I forgot to put my plus minus. Plus minus. There we go. So now I have negative 1 plus or minus the square root of 41 divided by 4. I look and see if I can simplify the 41. What times what makes 41? And 41 is prime. Since 41 is prime, I can't simplify this any further. You could, though, if you really wanted to, you could split this into two different answers. Negative 1 over 4 plus square root 41 over 4, and negative 1 over 4 minus square root 41 over 4. Both these together are our roots, our answers. Something I want to make sure you understand is We are using quadratic formula right now because we cannot use any other methods. We could try to complete the square. That might be one way to do these problems, but factoring is definitely not going to work. So let's take a look at this problem. This problem right off the bat, I notice that there's a 2 not where I want it. I want a 0. So we are going to subtract 2 from both sides. And if you really wanted to, you could get rid of the negative in front of the x by dividing everything by -1, but it doesn't really matter. But see, if you try to factor this, I mean, nothing's going to work. I mean, only 1 times 2 equals 2. And when you add those together, you get 4. And even when you try to, minus them, sorry about that, sorry, equals 3. And even when you try to minus them, you get 1. So neither this nor this is equal to the 2 that's right there. So that's why factoring isn't going to work. Quadratic formula is a sure way to always solve a quadratic equation. So let's identify A. A is -1. B is equal to 2. And C is equal to -2. So now we're going to start solving. X equals -b plus or minus the square root of b squared minus 4ac all over 2a. Alright, time to start solving this. Simplify what we can do. So we still have the -2 plus or minus. Underneath the square root sign, now I have 4 plus eight. And I made a mistake. I need to back this up a second. I was supposed to plug in a -1 for A. So a negative and negative is a positive, and then a negative and a positive and negative is still a negative. So this is -8. Sorry about that. Divided by -2. So underneath the square root sign, I have the square root of -4. All over -2. Now, remember, we learned a whole unit on complex numbers. We have a -4, so we can square root the 4, but of course we can't square root the negative in it, so we have to turn this into an imaginary number. So we rewrite this as -2 plus or minus 2i. Again, the square root of -4 is equal to 2i. And this is still all over -2. Please be mindful at this point that when you do divide by the number on the bottom, you are going to divide it into the first term, but you are also dividing it into the second term. Make sure you do both of these. So at this point we split this into two answers. One is -2 divided by 2 is 1 plus 2 divided by 2 is going to be 1i. For the other one, again, -2 divided by -2 is 1. Now the minus, and 2 divided by 2 is 1i. So these are our two roots, our two solutions, our two answers. So this is why we learned about I, because now you can actually deal with square rooting negative numbers when you are solving quadratics. Hidden inside the quadratic formula is another little mini formula called the discriminant. The discriminant is a quick and easy way to figure out how many solutions a problem is actually going to have before you actually do any solving. Underneath the square root sign, b squared minus 4ac, that's the formula that will give us the number of the discriminant. Now, we analyze the discriminant. What we do is after we plug in the b, the a, and the c number and work it out, we look to see, is the number positive? If the number is positive, then there are 2 real solutions. If the number turns out to be negative, then there are 2 imaginary solutions. But if it turns out to be equal to 0, then there is exactly 1 solution. The discriminant doesn't tell you the answers, instead it just tells you how many answers there's going to be and what kind of answers they're going to be. So let's try this out. So again, the discriminant formula is b squared minus 4ac. It's that part of the quadratic formula. So let's try it out. B in the first problem is negative 6 minus 4 times a in this problem is 1, and c in this problem is 10. So this is 36 minus 40. This equals a negative 4. And since this equals a negative number, so since it's a negative number, then there is exactly 2 imaginary solutions. Okay, 2 imaginary solutions. Let's try out this one over here to the right. So in this problem, our b is again negative 6 squared minus 4a1 times c8. So 36, and this time it's going to be minus 32 equals a positive 4. And since this problem has a positive number for the discriminant, then the answer here is that there are going to be 2 real solutions. I don't know what they are yet, but I do know that they exist. Let's try out this last problem in the middle. So in this problem, I have negative 6 is still my b, minus 4 times 1 times c. 36 minus 36 equals 0. So this one, our number is 0. So there is exactly 1 real solution. Again, the discriminant just tells you how many answers there's going to be out there. Is there going to be 2 imaginaries, 2 reals, or 1 real? It doesn't actually tell you. You would have to now use the quadratic formula to actually figure out what those real imaginary solutions might be. Alright, so if you have any questions, go ahead and leave a comment, and I'll see you back in class.